আমরা গতদিন যেটা দেখছিলাম application of optical properties, application in photoconductivity or photoconductive materials. Photoconductive materials, the the semiconductor diode is in reverse bias. Actually, is in reverse bias, and we saw the phenomena of photoconductivity. It is very useful in detecting light. Actually, it is very useful in detecting light in our laptops or in our many of our communication equipments uses this photoconductive instruments. Now we will see the next application in LED. All of you know what is LED, light emitting diode. A diode which emits the light. That is called LED. You have many things which have LED bulbs. তোমরা সবাই LED দেখেছো? Have you seen all? কেউ দেখো না এরকম আছে LED bulb? এখন বিয়েতে শাদীতে যেখানে যাও, all of you will get the LED. Now, what is LED? And how light comes from LED? Now, let us go to the next. LED. দেখা যাচ্ছে ঠিক মতো?
জি স্যার।
Okay, very good. Now, let us suppose this is a PN junction. This is an PN junction diode. This side is P and this side is N. PN junction diode. In the P side, holes are majority carriers. And N side, the electrons are majority carriers. Okay. Now, if we connect this diode by forward bias, we are connecting this diode by forward bias. Forward bias means this is negative, this is positive. Sorry, it will be, this is positive and this is negative. Now, what is this? This is the depletion layer. We have discussed many times about this depletion layer. This is the depletion layer before we connecting the battery to the forward bias. Before connecting the battery, this is the depletion layer. This is the depletion layer before connecting the battery. Now, if we connect the battery by forward bias, then this positive charge will repel the holes towards this way. This positive charge will repel the holes towards this way, and this negative charge means electron, will push the electrons towards this way. So this electron will go to this way, and this will go to this way. So what will happen? What will happen if the electron will go to this way? This depletion layer, you see, here the depletion layer is in this side, it is positively charged. In this side, it is positively charged, and in this side, it is negatively charged. In this side, it is negatively charged. And there is a potential barrier between this positive and this negative charge for silicon. For silicon, it is about 0.7 volt. Say for germanium, it is about 0.3 volt. This 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 potential difference of this depletion layer. Now, if the charge, if the strength of this battery is above 0.7 volt, say for example, this battery is of 2 volt. So the strength of this battery is above 0.7 volt. Now, what will happen? This 2 volt battery will push this electron. The electrons of this 2 volt battery will push this electron towards this way. And in this side, the hole travels towards this way. Now, as because this is only 0.7 volt, it will go through this way because the strength of the push is of 2 volt and the potential barrier is 0.7 volt. So this electron will go through this way, or this hole will go through this way by this path. By this path, it will go this way. Now, what will happen when the holes will travel through this way? Electron will travel through this way. A hole and an electron will attach with each other. This will travel through this way. This electron will travel to this way. So an electron and a hole will attach with each other, and we shall find a neutral silicon atom. Okay, or a neutral doped atom, or something which is very much neutral, because hole is positively charged, electron is negatively charged. So when they will attach with each other, then we will get a neutral thing, a neutral say, silicon. Now, this recombination, it is not like that. It is not like it is coming in this way, it is coming in this way, and it is coming in this way. They will meet with each other, and they will form a neutral substance. It is not like that. It is not like that. If you see, this is the valence band and this is the conduction band. Say, for example, this is the valence band and this is the conduction band. So where electrons resides, where this free electron resides, this free electrons stays in the conduction band. These free electrons are in the conduction band, and the holes are in the valence band. Why? How the hole is produced? The hole is produced when an electron from an atom goes to the conduction band, then this atom is a deficit of has a deficit of one electron, and it is called hole. And where is the electron? The electron is in conduction band. So to join a electron with a hole, the electron has to come from the conduction band to the valence band. And during this transition from the conduction band to the valence band, there is a energy difference, there is an energy gap. It will release some energy. It will release some energy as wave. It will release some energy as wave, and it will combine with the whole. So before combining the electrons with hole, the electron will release some energy because the electron is in conduction band and the holes are in the valence band. Always the hole will be in the valence band and the electrons will be in the conduction band. Because if the electrons will not be in the conduction band, the electrons will not free. It will be attached to the atom. After going to the conduction band, it will be free. And when it goes to the conduction band, when an electron goes to the conduction band, it makes a hole in the valence band. A hole cannot be in the conduction band. So hole is in the valence band and electron is in the conduction band. So if we see this figure, here the electrons are in the conduction band, that means in the higher energy, and the holes are in the lower energy valence band. So when they meet with each other, there is release of some energy as wave, as radiation. Say for example, the band gap of silicon is 1.1 electron volt. It is the band gap of silicon. So when this will come from here to here, it will release an energy of about 1.1 electron volt. We shall see, we'll see this. If we can see this wave, then it will be in the form of light. We can see this wave in the form of light. Now, can you tell me if one electron from silicon goes from the conduction band, from the valence band to the conduction band, and comes back and meets with hole? For example, this is silicon. One electron goes from valence band to conduction band and comes back to meet with hole to form a neutral silicon. And in this process, it has radiated energy. Can you see color? কেউ বলতে পারো আমরা কি কালার দেখবো কিনা? Can you see color? Very simple answer. Very simple answer.
স্যার দেখবো না স্যার।
Why? Why?
এনার্জি রিলিজের রেঞ্জটা তো স্যার দৃশ্যমান আলোর মধ্যে নাই।
Nine. Very good. Very good. The visible region is from 1.8 to 3.2 electron volt. So say for example, this band gap is 1.1 electron volt. This band gap is 1.1 electron volt. So when this electron will be back from conduction band to the valence band, it will release an energy of 1.1 electron volt. The wave, this wave, the energy of this wave is highest 1.1 electron volt. But the energy of the waves in the visible region, I have told you, it is about 1.8 to 3.2 electron volt. So to see the light, we have to release the energy from 1.8 to 3.2 electron volt range. So you will not get light from silicon. For this, a silicon substrate is black. You will not get light from this. So what will happen? We have many other semiconductors. Say for example, indium selenide. Say for example, gallium selenide, or say for example, gallium arsenide. For example, gallium arsenide. It has a band gap within the visible region of light. So any semiconductor will not give you light. Any semiconductor will not give you light at all. You have to have a band gap of about from 1.8 to 3.2 electron volt. And you will see the color, colored light. So this is called LED, and this is the principle of LED, light emitting diode. Which diode? All diodes cannot emit light. Only those diodes can emit light which have in which the semiconductor have a band gap of ranging from 1.8 to 3.2 electron volt light. We have red, blue, and green, three types of semiconductor LEDs: red, blue, and green. By mixing these three LEDs with different proportion, we can get different colored light. Say for example, if we mix green, blue, and red by the same amount, we will get the white light. And if we mix them by different amount, we will get the different colored light. So light emitting diodes, the principle of light emitting diodes are very simple. Just combination of electrons and holes. But you have to remember that the electrons are in the conduction band and the holes are in the valence band. Okay. Now, this is the principle of LED. Now, next one is solar cell. This is also a photovoltaic instrument, solar cell. All of you have seen the solar cell. Now, how it is made? How it is made? Solar cell is also an PN junction. It is also a PN junction. Yeah. It is simple PN junction. Say, for example, here the P say this is N part and this is P part. This is P part. This is N part and this is P part. Say this is N and this is P. So here electrons prevails and here holes prevails. Here holes are prevailed. Now you see in every PN junction there must have a depletion zone. There must have a depletion zone. This is the depletion layer. This is the depletion layer. The positive side. This is the positive side. It is negatively charged. It is negatively charged. And this is positively charged. This side is positively charged. Like that. Like the above one. This is the depletion zone. Here there is no P or no N. There is no P or no N. Only neutral atoms are there. Neutral, say, if it is silicon, actually it is silicon. So only neutral atoms are here. Now, sunlight comes through this way and goes here. That's why we have made the N layer is very thin. The N layer is very thin. We have made the N layer very thin. And the P layer is thick. The N layer is very thin. Why it is so? Because we want to allow the solar radiation, solar light to fall in the junction. That means to fall in your depletion region. We want to fall this solar light to the depletion region. That means where there is no P or no N, only neutral substances, only neutral atoms. Now, what will happen when light will fall to the silicon substrate? What will happen? The electrons will be free. The electrons will be free. The electrons will go to the conduction band. And the hole will be produced here. Electron will be free. Now, the freed electron will go to this side. Why this side? Because this side is positively charged. And this side is negatively charged. Then the hole will go to this side. Now, the electron, we are telling about the electrons. The electrons will go through to this side. If the electron will go this side, then say for example, this is the solar cell. We are making the three-dimensional figure here. Say this is the solar cell. Then what we did, we have made a metallic contact here. This is a metallic contact. This is a metallic contact, and this will come to this way. This will come to this way, and it is this way. This is the metallic contact. And this is the P side, and this is the N side. This is the P side. This is the depletion layer, N side and P side. The lower one is P side and higher upper one is N side. Now, this red one. This red one is the metallic contact. What will happen? Electron will go to this way. Electron will go to this way. And this metallic contact would collect the electron. This contact would collect the electron, and the electron will come through this way, this way, this way, this way here, and it will go to this way. So electrons will be collected by this metallic wire or metallic contact, and through this metallic contact, it will go to the P side, and from P side, it will go to this way to make these holes, neutral. So this is the very simple mechanism of solar cell. Now, what will be the circuit? Will be the circuit? The circuit is like that. It is coming from here. The circuit is like that. The electron will come from here and through this. This is the circuit. You see, it will come from here to here, here, and this. This is the circuit. Now, electron is moving on this way. So eventually, we will get current to this way. We will get current to the opposite to the movement of electron. So if we keep something here, if we place something here, it will get the current. The electron is coming through this way. If we keep something here, for example, you can keep here, say your mobile charger. So your mobile will get the current because it comes through this way. So through this way, your mobile is connected. So this. Now, what is the main thing? The main thing is we are getting direct current. We are getting current directly, not direct current. We are getting current directly from the solar light, from the sunlight. We are getting current directly from the sunlight. How? We are allowing sunlight to fall in the depletion region, and in the depletion region, this sunlight is producing electron. This electron is collected by this wire, and this will go through the PN junction towards the P side, and the electron will go again to the uh, to the P side to make more and more your neutral atom. So more and more neutral atom, the more and more neutral atom, the more and more sunlight will fall, the more and more electron will produce, and the electron will again go through this way. This is the simple mechanism of solar cell. Now, from a cell, from a this type of diode, from a cell, we shall get a very small amount of current. Not big, a very small amount of current, because the efficiency of this type of cell is very small. Efficiency of this type of cell is very small. What does it mean? Actually, the sunlight, when the sunlight falls, it produces here in this depletion region. Say this is the depletion region. This region, this is the depletion region. It produces electrons and holes here. Electrons and holes here. Now, we are expecting that this electron will go to this way, this electron will go to this way, and the hole will go to this way. But not always it happens. Many times this electron and this hole recombines again. By not going from here to here or not from here to here, it recombines again. For this recombination, we will lose many electrons. And next one, the nature of this PN junction. What about the next nature? Is it crystalline or a polycrystalline substance or an amorphous? This silicon in the PN junction may be crystalline. It may be polycrystalline. Or it may be amorphous. It may be crystalline, or it may be polycrystalline, or it may be amorphous. What do you mean by crystalline substances? That all the silicon are in the same direction. That is crystalline. All the silicon are in the same direction. But a crystalline silicon is very costly. A crystalline silicon is very, very costly. So to make the solar cell cheap, we can use a polycrystalline silicon. What is the polycrystalline silicon? This is the polycrystalline silicon where there are grain boundaries. This is the polycrystalline silicon. This is the polycrystalline silicon where there are grain boundaries. So in this grain boundary, in the polycrystalline silicon, in this grain boundary, some electrons will be lost. In this grain boundary, some electron will be lost. It is, say, for example, the electron is trying to go here, or is trying to go to this side, there is a grain boundary. It reflects in the grain boundary and it combines in the hole. If on the path of the electron there is a grain boundary, the electron will be reflected by the grain boundary. It will not allow the electron to go through this side, and eventually it will recombine at the hole. That means the electron is lost. There are other ways. Uh, mm, mm, uh, for for losing the electron. There are many other ways, but these are the main thing. So in the crystalline, fully perfect crystalline silicon, you will get only 28% efficiency. But in the polycrystalline silicon, if you use a polycrystalline silicon here, you will get only 15% efficiency. And if it is amorphous, that means there is no crystallinity here. It is only 4 to 6% efficient. But this is very costly. This is cheaper, and this is very cheap. This is very cheap. So, normally, the solar cell we see in our roof, it is actually made of polycrystalline silicon. But in our calculators, in our watches, we'll see some solar cells. It is of amorphous because in the calculator, very small amount of energy is required. So if we give the amorphous solar cell, in the calculator, it will be sufficient for us. You have seen in your calculator there are 3 to 4 solar cells, solar calculators, 3 to 4 solar cells or 5 solar cells. It is sufficient. It is sufficient because we require a very small amount of energy. But in that amorphous your silicon chip or a solar cell, only 4 to 6% of the solar energy is converted. Only 4 to 6% solar energy is converted. In the crystalline region or in the crystalline solar cell, you will get about 28% of the energy of solar cell. Solar energy. You can convert 28% of solar energy to the electricity. That is the now what will happen? This solar cell, one solar cell, either it is polycrystalline or it is crystalline, you will get a small amount of energy. So what you do, you can combine many solar cell with one another. Many solar cell with one another. Say for example, you can combine 36 solar cell with one another to get charge in a 2-volt battery. You have a 2-volt. If you have a 2-volt battery and you want to charge it, you will require about 36 solar cells combining together to charge a 2-volt battery. So this is the solar cell. তোমাদের কোথাও সমস্যা আছে বলো, কেউ বুঝো না কোনো দিকে এলইডি এন্ড সোলার সেল? কারো কোথাও কোনো সমস্যা আছে বলো, সবাই বুঝেছো? What is the problem in solar cell? What is the main theory of solar cell? সবসময় মনে রাখতে হবে, in the semiconductor the depletion layer is very much important. What is the depletion layer? আমার যদি depletion layer মনে না থাকে, then আমি এগুলো কিছুই বুঝবো না। Depletion layer is very much important. কেন depletion layer হচ্ছে? And which side is positive? Which side is negative? And what is the characteristics of this depletion layer? And how we can minimize the depletion layer or maximize the depletion layer? আমরা কিভাবে minimize করতে পারছি, কিভাবে maximize করতে পারছি? In the solar cell, you will find current directly from the sunlight. You are getting current directly. Now, can you tell me what is the difference between this solar cell and photoconductivity? Photoconductivity and solar cell, what is the difference?
Photoconductivity reverse bias
লাগবে, it will require reverse bias, but in solar cell
Forward bias, sir.
forward bias লাগবে। আর কারো? হ্যাঁ, মিম বলো দেখি, মিম বলো, what is the difference between photoconductivity and solar cell or photoconductive material or solar cell? photoconductivity এর মধ্যে কি আছে, মেইন থিওরিটা কি, আর সোলার সেলে কি থিওরি? দেখি মিম বলো। ও প্রান্ত একটুখানি বলেও দিয়েছে যে ও পুরাটা বলতে পারে নাই, photoconductivity রিভার্স বায়াসের দরকার হচ্ছে। and in solar cell আরেক প্রান্ত বলল যে it requires forward bias। তোমার কি মনে হয়? Is it correct?
Yes, sir.
It is correct. আর কারো অন্য কোনো আছে? নাফিসা, তোমার কি অন্য কোনো মত আছে?
না, স্যার।
এটাই মত না? অনেক কি বলো?
সোলার সেলে ডিপ্লেশন লেয়ার বড় করতে হলে তো স্যার রিভার্স
ওর কথা তো শোনাই যাচ্ছে না।
স্যার
দাঁড়াও আমি এটা লাগাই। হ্যাঁ বলো তো অনেক।
জি স্যার।
হ্যাঁ বলো। ওদের সাথে তুমি কি একমত নাকি তোমার ডিফারেন্ট কোন অপিনিয়ন আছে?
না স্যার, একমত।
একমত। ডিফারেন্ট অপিনিয়ন, একমত হওয়াটাই ভালো। ডিফারেন্ট অপিনিয়ন, একজনেরও কোনো ডিফারেন্ট অপিনিয়ন নাই?
স্যার রিভার্স বায়াস হওয়ার কথা স্যার, ডিপ্লেশন লেয়ারকে যদি বড় করতে হয় স্যার সোলার সেলে তো স্যার ডিপ্লেশন লেয়ারটা ইম্পর্টেন্ট স্যার।
না সেখানে সব জায়গাতেই ডিপ্লেশন লেয়ার ইজ ইম্পর্টেন্ট। ডিপ্লেশন লেয়ার ইজ ইম্পর্টেন্ট। আমি
তাহলে স্যার ডিপ্লেশন লেয়ারকে বড় করতে হলে তো স্যার রিভার্স বায়াস দেওয়া উচিত স্যার।
রিভার্স বায়াস দেওয়া উচিত। হ্যাঁ, আর কারো কোনো, আমি বলছি হোয়াট ইজ দ্য ডিফারেন্স বিটুইন difference between a photoconductivity and in solar cell, the theory in photoconductivity and in the theory of solar cell. Ajat ki bolo? Ajat?
স্যার আমি ওদের সাথে একমত।
সবার সাথে একমত। এটা ভালো, খুব ভালো, ভালো। Now, আজাদ তুমি আমাকে বলতে পারবে what is forward bias or reverse bias, যে কোন একটা। ফরওয়ার্ড বায়াস অথবা রিভার্স বায়াস কি জিনিস?
ফরওয়ার্ড বায়াস হচ্ছে ইলেকট্রন
তুমি 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 একটা পিএন জাংশন নিলে, পিএন একদিকে পি একদিকে এন তুমি লাগালে, একটা পিএন ডায়োড করলে, তারপর তুমি একটা ব্যাটারি লাগালে তাতে, তাই না?
স্যার
হ্যাঁ, এখন ফরওয়ার্ড বায়াসটা কোন দিকে হবে? পজিটিভটা কোন দিকে হবে? পি সাইডে হবে নাকি এন সাইডে হবে? ব্যাটারির পজিটিভটা পি সাইডে হবে নাকি এন সাইডে হবে?
পজিটিভটা পি সাইডে হবে স্যার।
পি সাইডে হবে, আর ওদিকে নেগেটিভটা এন সাইডে হবে। এটা হচ্ছে ফরওয়ার্ড বায়াস। ঠিক আছে, সবাই কি একমত ওর সাথে? ভেরি গুড। এখন তোমরা বলছো যে 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 ফটোকন্ডাক্টিভিটি the diode is reversed bias, but in the solar cell the diode is forward biased. Acha, very good. We see again. আমাকে বলো, where is the biasing here? আমি তো চিত্র আঁকলাম। Where is the biasing here? Is there any biasing?
স্যার এখানে তো কোনো
তাহলে তোমরা ফরওয়ার্ড বায়াস কোত্থেকে কথাটা বললে?
স্যার এখানে কোনো ব্যাটারির সংযোগ নাই।
এখানে কোনো ব্যাটারি নেই। So how it will be forward bias? এমনিতে আমি পড়ায় যাই, তুমি গল্পের মতো শুনে যাও, কিন্তু বাড়িতে গিয়ে না পড়লে তো এগুলো ভেরি ডিফিকাল্ট। ইট ইজ ভেরি ডিফিকাল্ট থিং এগুলো মনে রাখা। হ্যাঁ, বাড়িতে আমি যদি না পড়ি আমি একেবারে মারা যাব, একেবারে মারা যাব। এখানে ছোট 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 অনেক কিছু আছে। দ্যাট ইজ নো বায়াসিং। আমার ব্যাটারির কোনো দরকার নাই এখানে। I am getting current directly from the sunlight. এখানে আমার ডিপ্লিশন লেয়ারটা, it is original depletion layer. It is original depletion layer. Now, why we bias it? By adding battery to shrink the depletion layer or to extend the depletion layer. আমরা ডিপ্লেশন লেয়ারটাকে লার্জ করার জন্য or small করার জন্য we bias it. In the photoconductivity, we want the depletion layer is large so that we will get maximum amount of neutral atoms. So that we will get maximum amount of neutral atoms. And in LED, we shrink the depletion layer. Why? To recombination of electron with hole. We want that electron and hole will recombine to get light. So we go to we use the forward bias. But in the solar cell, there is no biasing, no battery. We can use the current directly. So what we do actually, we connect many solar cell one with another. Say for example, 36 solar cell connect, and we recharge a battery with that current. We recharge a battery with that current solar cell. You have a battery in the solar cell. You have a battery. তোমরা কেউ দেখেছো সোলার প্যানেল দেখেছো? যে কোনো বিল্ডিং এর মাথায় সোলার প্যানেল আছে, হ্যাঁ? They have a battery. Why this battery? To recharge this battery. Now, কিভাবে কি হচ্ছে? ব্যাটারি থেকে আমি কারেন্ট নিয়ে আমি লাইট জ্বালাচ্ছি। I am recharging my mobile phone from the battery. And by this way, battery is losing its current. And we are recharging this current from the solar cell. But in your calculator, we are using solar current directly. There is no battery. We are using solar current directly. That is a small battery. It is actually for your clock and other things. যখন ক্যালকুলেটরটা তুমি অন্ধকারে রাখবে তখন তো সোলার কারেন্ট পাবে না, তখন কিছু জিনিস এটাকে চলতে হবে। So for that we use a small battery. একটা তুমি ক্যালকুলেটরে দেখবে একটা ব্যাটারি দিলে এটা লাইফ টাইম চলে যায় in the solar calculators. But in solar calculator you can find the current directly, and here in the solar panels you actually recharge the battery and use current from the battery. আমরা আমাদের আইপিএস এ কি করি? আইপিএস এ কি করি? কারেন্ট আসলে ওই কারেন্ট দিয়ে আইপিএস টাকে রিচার্জ করি। দেন কারেন্ট চলে গেলে ওই আইপিএস থেকে আমি লাইট ফ্যান এগুলো চালাই। তাহলে এই যে আইপিএস এর কারেন্টটা রিচার্জ করছি, এই রিচার্জটা কোত্থেকে করছি? এই রিচার্জ করছি আমরা ফ্রম ইলেকট্রিসিটি বাই ইলেকট্রিক লাইন। Instead of using electricity, we can recharge the battery by solar electricity, by solar current, by getting current from solar energy. This is the way of using solar energy. এবার বুঝেছ? না এখনো বোঝা নাই? এখন বুঝেছ না বোঝা নাই? সিরাজ কি বলো? সিরাজ বুঝেছ না বুঝা নাই? আর মাইক্রোফোনটা অন করে বলো। বুঝছো? বুঝতে পেরেছ? না বুঝলে কিন্তু মুশকিলে পড়ে যাবে। না বুঝলে আমার কাছ থেকে ক্লিয়ার হয়ে নাও, আদারওয়াইজ তুমি মুশকিলে পড়ে যাবে, বলে দিচ্ছি আমি। কি মিম, এখন বুঝেছ না বুঝো নাই?
জি স্যার, বুঝতে পারছি।
বুঝতে পারছো? তুমি আমাদের ফার্স্ট গার্ল, তোমাকে বুঝতে হবে এগুলো, তোমার রেজাল্টটাও সেরকম হতে হবে, তাই না? তার উপরে তুমি আমার কাছ থেকে সই নিছো। এবার আমার পেপার যদি তুমি খারাপ করো, প্রথম আমি তোমার মাথা ফাটাই ফেলবো, তারপরে আর যা হবে হবে। বোঝো? না হলে আমাকে জিজ্ঞাসা করো, সোজাসুজি কথা একেবারে। এটা সবার ক্ষেত্রে, শুধু মিমের ক্ষেত্রে না, ফর এভরিবডি। হ্যাঁ, বোঝো? আমাকে জিজ্ঞাসা করো। হ্যাঁ, কিন্তু জিনিসগুলো ক্লিয়ার হওয়া, এটা হচ্ছে কথা। Now next one, let's go to the next one. It is, আমি স্লাইড করেছিলাম, স্লাইডে তো যাচ্ছি না। পিএন জাংশন, দেখো পিএন জাংশন সোলার পাওয়ার সেল, ওকে, এটা আমরা পড়েছি। নেক্সট ওয়ান ইজ অপটিক্যাল ফাইবার। Optical fiber. How optical fiber works. How optical fiber works. Now, let us see how it is. Okay, আমরা লিখেই করি। Refraction. What is refraction? What is refraction? আমরা refraction পড়েছি। What is refraction? Say for example, this is a prism. Refraction. Say for example, this is a prism. If light enters in the prism like this way, if light enters in the prism, it will bend here. And it will bend here again. It will bend here again. Not this one, it's this one. So this is called refraction. I told you earlier what is refraction. When light passes from one medium to another medium. Say for example, this is air and this is glass. This is air and this is glass. So when light passes from one medium, say for example, air, and to another medium, that is glass, its direction is bent. And when it passed from glass to air, it bended again. Its direction changed. That is called refraction. That is called reflection. I told you earlier. And what is the cause of this reflection? Because of the dipoles. I told you earlier. Because of the dipoles. This is called refraction. Now, this refraction, we can change this amount of refraction. We can change the amount of refraction by changing the medium. If it is not glass, if it is water, then the amount of refraction will be different. In the glass, it is one, and and in case of water, it is different. And in glass, there are many different types of glasses. So the amount of refraction also will be different. Now, let us, if we inject the impurity in this glass, if we inject the impurity in this glass, the amount of refraction also, say for example, this is and this, the amount of reflection also be different. And it may be like that, it may be like that if we add impurity so that and more impurity, if we add more impurity, it will be this way. This is called total internal reflection. Light is not going out. It is again coming to the prism, inside the prism itself. It is called total internal reflection. It is called total internal reflection. Amount of reflection can be varied. The amount of reflection can be varied by adding impurity in the medium. And the reflection is denoted by a term what is called refractive index. What is refractive index? Velocity of light in vacuum divided by velocity of light in the medium. Velocity of light in the medium. Actually, what happens? The velocity of light is decreasing in the medium. The velocity of light decreases when it passes through more denser substances. It decreases. Now, we can make total internal reflection by different way. What is that? Total internal reflection. Total internal reflection by different way. Say for example, this is a reflection. Again, this is a reflection. This is a reflection. Now, if we change this, direction, if we change this by this way, then the reflection will be here. Then the reflection pattern will be this. If we change this by this way, then the reflection pattern will be this. And if we change it by this way, if we allow the light to fall by this way, then the reflection will be totally internal. If we change the angle of falling of light, then the total the amount of reflection or the refraction changes, and ultimately we can find a total internal reflection. তোমরা কি বুঝেছো ব্যাপারটা? What is total internal reflection? আমি কি করেছি, ইনসিডেন্ট লাইট, অ্যাঙ্গেল অফ ইনসিডেন্ট লাইট আমি চেঞ্জ করে দিয়েছি। অ্যাঙ্গেল অফ ইনসিডেন্ট লাইট যখন আমি চেঞ্জ করব, তখন কি হয়ে যাচ্ছে যে অ্যাঙ্গেল অফ রিফ্রাকশন also be changed, and ultimately we will get the total internal reflection. Now, this is the theory of your optical fiber. Optical fiber. Say, for example, this is a fiber. This is a fiber. This is a fiber. Now, আমি লাইটকে এমন ভাবে পাস করেছি that there is a total internal reflection. There is a total internal reflection. I have passed the light to a certain angle, to a certain amount of angle, so that there will be a total internal reflection. Will be a total internal reflection. So light can pass through this fiber very easily. This light will pass through this fiber very easily. That means what? This is not vacuum. This is say, for example, this is glass, and this is another type of glass. This is another type of glass. This is one type of glass. This is one type of glass, and this is another type of glass. It made so that the angle of falling of light is like that, and this angle is made such that the light becomes in total internal reflection. So the light cannot go through this way, or it cannot go through this way. It is totally internally reflected. So you can pass light from here to here. This is the optical fiber. This is the optical fiber. This fiber is like a human hair, on human hair. And this is one type of fiber. Say, for example, this is a fiber. This is a fiber. And this is the cladding. Cladding means in this junction of this fiber and this fiber, in this junction, this light is totally reflected. This light is totally reflected. So it passes from here to from here. Now, why it is required? Why this optical fiber is required? Why optical fiber? Why optical fiber is required? Can you tell me why optical fiber is required? Anybody? how we are getting the information in internet, or how we are talking by mobile phone, how we are getting the information. Say one information you want information from Google, how you get it? You have typed what is optical fiber, optical fiber. In the Google, you have typed what is optical fiber at the Google. Then this W is a series of zeros and ones, eight letters. 1, 2, 3, 4, 5, 6, 7, 8. This is 8. This W means 8 letters of zeros and ones. Like this, H means 8 letters of different zeros and ones in different combination. So এই W-টা কি হয়? 8টা 0 and 1 এ converted হয়ে যায়। These zeros and ones becomes the pulses of light. এই 8টা 0 and 1 becomes the pulses of light. This light goes through this optical fiber, where in America, where the control room of Google is situated. From there, it collects information again by light. This will come through this optical fiber, and this light is detected again in my laptop or in your mobile by a photo detector and make zeros and ones and then again W. তাহলে কি হচ্ছে ব্যাপারটা? তুমি মোবাইল ফোনে কথা বলছো, what it will happen? একটা রেডিও ওয়েভ যাচ্ছে, এই ওয়েভটা is collected by a center. তোমার আশেপাশেই দেখেছো অনেকগুলো লম্বা 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 ক্যাচার আছে। From that catcher, electron light pulses is made in that catcher, and this light pulses goes through America, goes through everywhere. এই যে আমি তোমাকে কথা বলছি, তোমার সাথে কথা বলছি, এটা কি হচ্ছে যে it forms a light pulse, it goes towards America in the zoom center, and from that zoom center again it comes to your ears. So যেখানে তোমার অপটিক্যাল ফাইবার নাই, সেখানে ইন্টারনেটও নাই। We call them as submarine cable. তোমার সমুদ্রের তলা দিয়ে চলে গেছে জিনিসগুলো। Now this light cannot pass about say 100 kilometers. 100 কিলোমিটারের বেশি পাস করতে পারে না this light, because it will lose in the path. It will lose something in the path. এই লাইটটা কিছুটা লুজ করে যায়, লস্ট হয়ে যায় লাইটটা। সো কি করা হয়? আফটার সাম ইন্টারভেল সেখানে একটা হাফ বসানো থাকে, যেখানে কি হয়, লাইটটাকে স্টিমুলেট করা হয়, স্ট্রেংথ দেওয়া হয় লাইটটাকে, সো দ্যাট ইট ক্যান গো। তাহলে সমুদ্রের তলায় কি হয়? সমুদ্রের তলায় হয় কি, যে এখানে আরো একটা কপার ওয়্যার দেওয়া হয়, এই জায়গাটা একটা কপারের একটা দেওয়া হয়। এই কপারের এটার ভেতরে তোমার এই কপারের ওটার ভিতরে দিয়ে একসাথে কারেন্টও পাস করানো হয় যাতে ওটাকে স্ট্রেংথ দেওয়া যায় after some interval, after some interval, after some interval. This is the theory of optical fiber. So what is optical fiber? Very simple. The total internal reflection of light. Total internal reflection of light. তোমরা কতগুলো ফ্লাওয়ার ভাসের মতো দেখেছো যে this is, say for example, this is a flower vase and it is coming like that. Small strand like এখানে একটু আলো, 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 and it is also lighted. এরকম দেখেছো ফ্লাওয়ার ভাস? বিয়েতে টিয়েতে উপহার দেয় অনেক সময়। হ্যাঁ, these all are optical fibers. এখানে লাইট সোর্স আছে, এখানে লাইট সোর্স আছে, লাইট কি করে এখানে যায়, এর ভিতর দিয়ে লাইট এসে এখানে পৌঁছে। It is also illuminated and it is also illuminated. This is optical fiber. So if we see now here, input signal encoder, electrical to optical converter. Actually, input signal, what is input signal? What is optical fiber? You have written, this is an input signal. And encoder means 0, 1, 0, 0. For every letter, there are 8 encoders. There are 8 zeros and ones in different permutation combination. For every letter, there are 8 zeros and ones. So this is called encoder. So W becomes zeros and ones, H becomes zeros and ones, A becomes zeros and ones by an encoder. This encoder supplies that zeros and ones to the electrical or optical converter. What optical converter does? The optical converter makes them pulses. 0, 1. That means you will get light at 1. You will not get light at 0. That is 0 and 1. 0 and 1. Getting light or not getting. Getting light or not getting. Getting light or not getting. Now this goes to a fiber optic cable. This is fiber optic cable where that lights passes through this cable without any internal reflection. Now, what is repeater? Repeater is the hub where light is extended. Why? Because after some time light loses its energy, so repeater gives it energy and it again goes to the optical converter, electrical converter to America or to Russia or to India to get the answer. Then it becomes again zeros and ones and it becomes W again. So this is the working principle of how we'll get the light. We'll use the light for getting the information. Now this is the optical fiber. You see, these are the fibers, very thin, like human hair. You see, this is the core. This is the core by which the light travels, and this is the cladding. This is the cladding. In the junction of core and cladding, there is a total internal reflection, and this is the This is the polymer sheathing. So here is the total internal reflection. This is the optical fiber, or what is fiber optics? Total internal reflection. Okay.